share this. Okay, so let's start from the beginning. It's being recorded. So hello everyone, this is a Geneva DevChain meetup September session. Let me share you the agenda for today and share my screen. Oh, no. Okay, everyone you can see. So we will start with a quick overview of the market between me, Jean-Marc, and Cyril. Cyril is running here in Switzerland the DeFi community and want to talk about some few things happening in the last month. Then we'll go directly towards the main topic, which is the Algorand and the borderless economy. So Pietro will kick off with the economical advancements and business cases the Algorand is solving today. And Russell Faustino, the Algorand developer advocate, he will explain how this Algorand is solving it from the technical perspective and will demo to us few solutions. And then I will show you the Algorand Builder beta release. So this is what we do. One thing for our community, so as you know, we are now focusing mostly on Slack. However, there was a long discussion about moving to Discord. So if you would like to voice your comment, please go to Slack. There is a poll about like where you would like to go. If you would like to stick with Slack, Discord, or propose anything else, yeah, go there. So what's next? Hackathons. There are a few big hackathons happening now or soon. One is the Hack the Rainbow. So that's near it's a blockchain focusing on sharding, trying to solve sharding problem. It's a very, very hard thing. They organized the hackathon. We as a Geneva DevChain community, we received a promo code. It's on our Slack. I will also post it in the chat. So the promo code will give you a 10% boost if you win any bounty. So the hackathon starts mid-September. Another one, big hackathon, is Chainlink. They recently sponsored a big conference this weekend, the previous weekend, and they are organizing hackathons from 7 to 27 September. So that one is a long one. Also, lots of bounties, lots of things happening. Okay, and now we go to the markets overview. Things I wanted to share with you. I was super surprised that the yield finance surprised the Bitcoin price. I mean, how far it can go. I was super surprised. We can talk about it a little bit later with Jean-Marc and Cyril. But a few other things on the market. So the big project Polkadot, they went on multiple exchanges. Cosmos SDK Stargate release, so the long one, big expectation, is planned to have a release candidate in September. What the Stargate is coming with IBC protocol for inter-blockchain communication, protobuf migration, and tons of other things. And something else, that's in fact what Jean-Marc Senior was sharing recently on our DeFi channel, SushiSwap. So they want to, there's like a big rival to Uniswap, and they want to say that they are 10% better, or 10 times better than Uniswap. I don't know how this will work. So let me pass now to Cyril. Cyril, would you like to comment on what are your observations about the market?
So what you say is very very correct. I would have add as well the point of Jan 2 weeks ago, which completely put the or destroy the Ethereum, not destroy, but disrupt for 24 hours the whole Ethereum ecosystem. And so YAM is one thing. And also I published, I was invited to comment on the DeFi ecosystem on the Beetle magazine on Monday. And I wanted to stress that now we are discovering in DeFi that gamification might be a very interesting thing for finance. So I will be very interested to have your thought. I'll let you think about that. How gamification can be a disrupting factor in decentralized finance and in finance in general. So that's all for me.
Thank you, Cyril. So, by the way, did you also check this sushi swap? Like, do you have any thoughts about sushi swap to say?
Not specifically about Sushi Swap. It's very hard to be followed. It's part of the gamification and this whole bubble right now on DeFi. So definitely to be followed.
Cool. Yes, and it's also worth to point out that the prices on Ethereum are really skyrocketing. So the simple transaction, the Ether transaction, costs about $4. If you want to do it fast, it's $16. Transferring ERC, it's way more expensive. Operation on Uniswap, it's more than $50. Yes, so it's not on hard times. And Algorand is solving that. We'll see it today, later on. So Jean-Marc, I would like to invite you to do some comments. And first and foremost, maybe you would like to sell also a little bit of the upcoming CAS studies, yes, happening now. So I will stop sharing my screen.
Okay. Yeah, so basically, do you see my screen now? I think you should see it, right? You see my screen, right?
Yes.
Yeah.
Yes. Okay. So the CAS is what we call a Certificate of Advanced Studies at University of Geneva. It's an official course that when you finish it successfully, you get this certificate, and which is worth what we call the 12 European credits. So these credits are recognized in many European countries. And also sometimes if you go to the US, you have also, they can be used, they're also recognized by some US universities. So we start with the business and legal aspects where anybody is welcome. We cover blockchain, cryptocurrencies, and as you have underlined, decentralized finance is more and more important. So we have also introduced decentralized finance information. So for decentralized finance, yes. So you talked about IFI, Yearn Finance. As you underline, okay, the price of its coin is above the price of Bitcoin, but the supply is much lower. The supply is around 30,000 coins compared to 20 million Bitcoins. Then it's one point. It's an advance from a decentralized finance point of view. I think we have seen that, it started with exchange, decentralized exchange, when you can swap coins. Then you had also lending, and Yearn Finance is bringing more advanced services on top of that, more complex also, where more bugs may happen because there is a combination of lots of different parts. In addition, they don't do audits before putting their code in production. So there's a lot of risk in the combination of all these different services and layers. And another point from the value of Yearn Finance, it's not valueless because actually the owner can vote. It's a governance token, so they can vote how much percent they can get from a treasury, and the treasury is quite worthy because if we compare how much the money, for example, even Uniswap some days does more than $50 million in fees. So over 10 years, for example, you could reach hundreds of millions, billion, and if you have 0.03% of the fees inside this treasury, still, I mean, it gives a quite high level of value just from this point of view. So yes, this is the most advanced. They are working on a insurance product now, yearn insurance. So yeah, it's pretty interesting project. You talked about also, I think, sushi. Sushi is the same. Their code is not audited. They copied most of the code of YAM. So the risk then of a bug is important, and that's the reason after we have the business and legal aspects covered, we can go beyond the idea and try to implement it. So we have partnerships with a number of blockchain and DLT, decentralized ledger technologies. This year it's new. We cover Hyperledger which is taught by IBM. Ethereum, actually, it's mostly Robert and Cyril also. They teach parts of this. We have a partnership with Hedera Hashgraph to give to cover also a DLT, which is not a blockchain but a Hashgraph, a DAG. And we have also a partnership with Libra because it's based in Geneva, and then we had good contacts with them. So from the idea of module 1, which is open to anybody, then the programmers can do the full course and implement the idea. There is a lot of mentoring. We give a lot of feedback to them from the technical to the legal aspects. We have lawyers covering the legal aspect. So we cover, of course, a lot Swiss legal framework, but we have also a lawyer from France. We cover Malta, and there is also a law professor from the US to cover some other jurisdictions. So that's the overview of the course and how it is linked to decentralized finance.
Thank you, Jean-Marc. Yeah, maybe we'll see after the session there will be some initiative to add Algorand. Who knows?
Yes, we can of course consider this. Yes.
And last, maybe quick question, Cyril, is the article you mentioned available online? Okay, maybe he's.
I think it is.
So maybe it will be worth to share it here on the Slack. Okay, so with that, thanks for these updates, and I'm leaving the stage for maybe, let's say, Russell. He will say a word about the Q&A, and then we go with Pietro.
All right, great. Thanks for having me, and thanks for organizing this online event. How have you folks been doing with the meetups online? Have you been doing that for a while now after the COVID, or you've been getting a good number?
At the beginning, when the lockdown started, yes, we got a very good traction.
Yeah.
But then down the line, it was declining.
Well, it's not too bad today. It looks like we got over 30 here on tap. I did put in into the chat window the link. Whoops, it didn't copy over right. Let me get that in there. Sorry about that. Bitly won't do the trick by itself. There we go. So that's the link to my PowerPoint. If you're online here for the first time with Zoom, get familiar with the chat window as well as the participant window. Those icons are located at the bottom of your main control panel. And also, I have Ryan Fox here from the office. It's going to be helping out with the Q&A. Ryan, want to say hello to everybody?
Hello. Good afternoon, good evening, good morning to everybody. Happy to answer questions in the chat window. So I look forward to connecting with you guys there.
All right. And so let's go ahead and get started. I'm going to go ahead and share my screen. I've got some really great stuff here to show you today. and I can't wait to get going here.
So should be Pietro now, like with his presentation, but maybe you want to mention about Slido. And,
okay, sure, yeah, that's a good idea. So I'm going to post into the chat window a poll question link that'll help me get the makeup of today's audience. And let me go ahead and get that poll started on my end first. Here we go. Okay, so if you can take a look at, I'm going to share the screen too, so there's a QR code as well that you can use. And, oh yeah, I gotta, hold on. Share my screen would help here. Okay, now we're cooking with gas here. All right, and let me go ahead and bring that up. And there we go. Now we got everything fired here. So if you can go ahead and either scan that in or take a picture of it, or just go to slido.com and enter in that number. You should see a poll that is currently being displayed. And let's see, where is it?
it's here. So you have this pool, and it works. So when I click on it, especially on my mobile, yes, I have two tabs. On the top, I have a poll, and which start, are you the developer? And on the left tab, there is a Q&A, and this is what we should use for the questions, right?
Yeah, we're going to use the chat window for the Q&A, and now we're getting the responses in as well. And we'll share those results in a second. And looks like we got a good number of folks here that are developers. So looks like we got good number, and let's continue to the next poll that you have there. Okay, so we'll go ahead and go over to the next poll. All right, what kind of programming language do you use? You see that? So if you can like to enter this information, that'd be great.
And maybe, can you also send it to, did you send it as a link?
Yeah, the link is in the chat window for the poll questions, and this QR code back here is also will get you there, or just go to slido.com and put in the 55846. So we've got half of you are doing the Python, half are JavaScript, half are Go, a few Rust and others. Java at 22%.
If you scroll up, you will see that JavaScript is leading now.
Yeah, oh, okay. Python's amazing, you know. I started using that in the past year, and it's just, I do all the, a lot of the demos, you know, in different languages, and it just always seems like Python has the fewest lines of code, right, to accomplish something good. It just seems like the easiest. It's amazing. It reminds me of the old Visual Basic days. All right, let's go to the last poll here. How experienced are you with blockchain? Year or less, brand new, more than a year.
So by the way, for the previous JavaScript one, it got like more than 60%. You just scroll down the window and you didn't see the first one.
Okay, all right. All right, very experienced crowd for the most part, more than a year, 90%. That's excellent. Okay, and let's go ahead and close this out. And Pietro, which island are you? I live in Tampa, Florida, about 30 miles north, right in the Gulf of Mexico. I am not presenting from the Gulf exactly, about 3 miles away, but amazing what we can do with these backgrounds. No, don't ask questions here. Just go ahead and put those into the chat window. And I think we're in good shape here now at this point. All right, so I'm going to go ahead and close this up. Let's go back out to the deck, and I'd like to welcome everybody. We're going to be talking about Algorand blockchain, everything you need to know, at least in September. We have constant new enhancements, it seems like, with the Algorand blockchain. You're going to really enjoy the latest set. We'll talk about that as well. One thing I did not do a poll for is if you are already using Algorand, why don't you go ahead and go into the participants list and just click the yes mark or no mark. So the question is, are you currently using Algorand? And so let's go ahead and see if we can get a show of hands here on this as well. All righty, and so we did this, and let's go ahead and get started. We do have a contest today, so we're encouraging folks to sign up for the developer newsletter. Even if you're not a developer, sign up anyway. You'll get this really nice looking email on a weekly basis, everything new on the developer portal. Plus, you'll be in the running for some Do-Re-Mi. I've got a Amazon gift card to give out at the end of the session. So this is a live, poll that we're doing. So $100 Amazon gift card is what we're seeing here. So go ahead and if you just go to developer.algorand.org, we'll just go ahead, go to the footer. You can see there's a newsletter link as well that'll bring you to this page's newsletter page. So I'll show this one more time when we get close to the end, but right before I get done, we will go ahead and do that. So it looks like 4 have used, 2 haven't, and everybody else didn't answer. So we got some experience here with blockchain on Algorand. That's great. Get the goods. Go ahead and I posted this link already for the PowerPoint. The code I am going to show you. Let me bring that up here. A lot of the code I'm going to show you is what we call hot off the metal. And as such, some of it hasn't made its way to the developer site, but most of it's there. So what I want you to do is if you click on the docs features link and you drill into any feature like ASA at the bottom of the page, you'll see a link to the actual source code, and there you can see it. That would be at the bottom of the page. So that would be like coming from, say, this feature section. You have, we'll go into like assets, and then you go like to the bottom of the page. All of these feature pages have the examples, and we'll talk about V1 and V2 in a minute. V2 is the one you want to go with. That's the new version for the SDKs and REST API points, and so that's where you would get the majority of your code. I think there's one example, the rekeying Python, that hasn't made it out to the doc site, so I did temporarily put it up into the hackathon repository for DevRel, and so that should be available here when I get to that as well. So it's very important. I know I always get questions on where's the PowerPoints and where's the code. So we got that covered, and I can always post those into there again. So problems with blockchains, say I have a long running, public address, and then I want to change the authorized private key. What you had to do is create a duplicate account, and the signing key has been wired to that one account, and there really hasn't been much flexibility. So we'll see what's happened there in the way of easing that pain. Also, I have an account signing my transactions, but I want to change it to a multi-sig or a logic share. How do I go about doing that? Again, we'll take a look at exactly how over the course of this session. And I create a node and cannot use it for days, right? So, catching up from the Genesis block really does take days. It takes forever. And, it's funny because one of the first hackathons I went to over a year ago that Algorand sponsored, at that time, it took about 6-7 hours to catch up. So the first day of the hackathon was really shot. We didn't have other alternatives at that point for accessing the Algorand blockchain. Times have changed. We have many options now, and you can just be going really, really quick, in terms of getting up and running now. So we'll take a look at how that's done. Also, the cost and speed of other smart contracts make business models hard, UX spotty, and really tough to implement. We'll see what we do with smart contracts here at Algorand to really ease that, and really having really some excellent new features as well. And then finally, how do I do searches on a blockchain and quick? I know when we first came out with assets, one of the questions I had is how do I search all the accounts that have this asset? So for example, maybe I'm creating a game and I've got tokens in the game that are Algorand assets, which are basically tokens that you can create on your own for those that are not familiar with some of our layer one features just yet. Well, it is, a tough query to do, to believe it or not, to come up with all the accounts that have this particular game token. Then I could build a leaderboard, for example, from that, and list folks there. So this has been solved, and we'll also take a look at how to do that over the course of this session. So the agenda here is we're going to cover Algorand layer one features. I'm going to go about an hour here today, and we're going to I'm just going to go ahead and note where we're at here. So I want to go to about 1:30 or so my time and try to get you all this information. We've got fast catch up we're going to talk about, rekeying, Indexer V2 is killer, the Algorand Foundation rewards program. Also, you have developer tools, lots of developer tools, many developer tools. So this is a good place to be. Then also some community resources and lots of code. We'll end with a lot of great demos here. So why Algorand? Yep.
Russell, sorry just for stopping for
no
a moment.
problem.
Before going to, let's say, the dev mode, because you have like a great agenda which goes from like an overview and value proposition down to the development mode. And we have few people who are really want to see and stick a little bit more in the business. So before going into the dev mode, could you do later on some transition or whatever you find it useful to Pietro? So he will talk on the business advancements in this economics. So whenever you find it suitable, yes, but before.
By the way, I think that this slide is perfect to transition to the business fallout, because the why Algorand logic actually is absolutely the key to the adoption that we are seeing today from our clients, right?
Exactly. Yeah, that's really this first few slides I've got on tap here, and thanks, Pietro. That is very true. The fact that we use a peer proof of stake consensus, and this facilitates a very efficient blockchain that scales to billions of users, and then you also have enterprise speed. With over 1,000 transactions per second, and each block is created in under 5 seconds. There is instant finality. There are no soft forks. It's very cost effective, in terms of the less than 100th of a penny, right, USD cost per transaction. So very good in terms of the scale. And then also, technical innovation continuing to drive adoption. We're looking at tracking 10 million users on chain by end of the year, estimating over a million transactions per day by the end of the year. And just look at this list of users now on our landscape. You know, from the technical side, we've got a few explorers out there. We're the Algo Explorer, Goal Seeker to go ahead and do searches by anything: transactions, accounts, assets, applications, smart contracts. You got also BitQuery, Algorand Builder, PyTeal, Algorand Signer just got released yesterday or the day before. We've got SDKs in Java, JavaScript, C#, Python, Dart, Rust that are available. A couple of those are our community. The four that Algorand directly supports are Java, JavaScript, Python, and Go. And then you've got financial firms and looking at integrating here with our blockchain between Coinbase and Binance and KU Coin and BitZ. And then finally, really the ecosystem of applications. Now you're starting to see a lot of applications built onto, you know, our system. And this is really a great time to be a developer on blockchain. I mean, this market is really growing. There's over 100,000 developers out there now that are developing with blockchain. You know, it's not going to be a white elephant. I can tell you that much. I know it's a big fear a lot of developers have is which, you know, technology should I learn next? So those that are brand new, this is really a great technology in terms of, you know, learning about blockchain period, then also learning about Algorand blockchain specifically. So you get things like World Chess is on our blockchain. Asset Block is another one that will divvy up the assets and parse them out, you know, to multiple folks very, very efficiently. You've got a lot of great solutions here that are coming out almost daily now on the blockchain. And we've had our mainnet running now a little over a year with over 384 companies that leverage Algorand's platform. You've got you know, global exchanges, including Coinbase and Binance. You got asset issuers, like Republic, for example. We are one of two blockchains with the top two stable coins, USDC and USDT, and supported by industry-leading custodians in the crypto market, right? As well as over 300 ambassadors now. In fact, actually, it's over 400 ambassadors, and that's like our most valuable professional MVP type program that we have here at Algorand. And the downloads are being used, over 50,000 downloads, you know, of our SDKs. So lots of great stuff happening there in the landscape. So what I'm going to do here now is go ahead and dive into the layer one features. And let's go ahead and continue on with, we're going to talk about Algorand accounts, rekeying, Algorand standard assets, atomic transactions, and smart contracts. So 3 different types of accounts. You have an individual account, you have a multi-sig account where you have a threshold. Say you have 3 in it and you want at least 2 to sign it. Your threshold would be 2 to get that particular transaction signed. The newest entry here is a logic account or an LSIG, which always returns true or false. So if it returns true, you'll go ahead and sign it. And there is another option to also have an account sign that as well if it does return true, and that's a delegated account, and I'm going to show you both of those samples in the code. And really that's the way you think about this, and not just accounts but who's signing off on it, right? So on the left, the standard account, the individual account would be signing off on a transaction. On a multi-sig account, the account was then signed off once that threshold is met. And then finally, you get the logic sig account, which is signed off when that returns true. So that's the best way to think about these. These are actually related to signing. And then, so rekeying accounts is a very big new feature that just came out where you just have a public address, for example, and you want to say, oh, I want to switch this to like a multi-sig kind of an account. You know, how do I go about doing that? Well, the way rekeying accounts works is basically you would go ahead and treat the signing independently of the account. In other words, we separated the coupling. So to create a new signing, you don't have to create a brand new public account. You can say, okay, I'm going to authorize, you know, I'm account A, I'm going to authorize account B to do the signing. And then there's just another field on the transaction to facilitate that. So very clean implementation, very, very flexible. I have more information on that as well. We're going to expand on that. So Algorand standard assets, or ASAs. This is our layer 1 native token that you can create. It's native like the algo itself. The algo is our cryptocurrency. And it is you know, created in minutes. There's no on-chain code. An administrator can do several functions like mint and burn, or freeze access, or revoke an asset, or delegate. There's also asset spam protection because you need to opt in to a particular account. I'm going to show you a quick demo here of one of third-party controls or tools here. Algorand ID, Algo.io. They also have a teal editor here as well that you can use, but we'll just go ahead and click on the asset management. So this is going to be our mnemonic for our account. We're going to go ahead and get started. And so let's go ahead and create an asset, and we just call it, you know, my asset. And then you have total supply you want, URL, unit name. I'll go Rustcoin September, and then we've got all the addresses, right, that are associated with that mnemonic that came up that you can always restore account from is listed. So just like that, we get a unit name that's too big. Error. I wish I would have caught that before I did it, but basically you get the idea here. It needs to be a smaller length. Yeah, so let's go ahead and do that real quick here. There's coins, we'll call it 9. Okay, there we go. Total supply 1,000. Decimal points, you know how many you want over. So if I do 1 decimal point, that's really 1,000 tokens. And then now let's go ahead and create this. And so there is the result right down over here. You can see I've got, you know, folks have got all their list up here of assets. So very, very easy to create. And it really is a good tool. I'm actually going to show you how to do that in the code later on. And so what we'll do is take a look at this next screen here, and this is about Algorand atomic transfers. So this again is a native function on layer 1, and atomic transfers is a native function instead of implementing with third-party contracts. So there's no need for a hash time lock contract, and very easy and secure. For those that are familiar with like SQL database efforts, is basically you know, you can have several transaction tasks that make up a transaction, and if any one of them fails, everything rolls back to the way the database was beforehand. This works exactly the same way. So if you have a person A that's going to send 50 algos to person B, that will be approved if and only if person B sends the actually sends a concert ticket over to person A. Once that whole thing is complete, everything will go on the blockchain, and that'll be a great way of doing business, especially with people that you know, you really don't know anything about, right? So it provides you know, a great way of doing it in a trustless kind of a system. So Algorand smart contract. So this is the transaction execute approval language, where you actually have the contract on Algorand as described in teal. Teal is like an assembler type of language. There's also a Python enabled compiler called PyTeal that can be used, as well as two types of smart contracts: stateless, so that's used to approve spending transactions, and just released with the August upgrade is stateful, on-chain, global, and local storage. So very powerful now in terms of the types of contracts that you can actually write. We'll be going through some of those in the demos as well. Combinable with other Algorand technology. This is an important point to make. So you can combine smart contracts with atomic transfers, with Algorand assets, and combine stateless and stateful contracts together as well. So a lot of different scenarios. So this is a little bit of a high level slide on Teal. It's a bytecode based stack language. It returns true or false. You know, there's no VMs running on the blockchain. VMs are very heavy in heavy weight. So that was the thought process behind providing a very lean and mean stack-based language. And really all you wanted to do is return true or false to do signings. There's over actually 90 opcodes, I think, at this point. You have access from Teal to ASA or algo balances. You can read through all the transactions in a group. You have stateful capabilities, again, with global and local storage calls. Stateless can provide signature verification. And again, there is a PyTeal library to write this all in Python if you wanted. So this is kind of how it works. You got a list of different transactions over here on the right. We're going to go ahead and add the close to remainder to the stack, and then convert the byte address constant and push to the stack as well. And then pops the two values off the stack and replaces with a 1 or 0, depending if they were equal or not. And then here's an example of what the Python code would look like that generates and returns the Python, the Teal, actually from the Teal code, right from the Python code. Also a great video to watch. Again, you have the deck link in the chat window. And this is something that I think I'll put it in again, just in case anybody joined late. I'll go ahead and put this PowerPoint in there to everybody. So there it is again. And so you'll have all the links that are in the deck as well. So let's talk a little bit about stateless smart contracts first. So this replaces the signing of transaction. There's two usage modes. One's a logic account. And basically any transaction sent from this account will be verified by the predefined logic. So in other words, the logic returns true or false as to whether it gets signed or not. This is great for escrow style accounts, split payments, HTLC contracts. And then you have a logic signature. So any transaction signed with the signature will be verified by the predefined logic. So in other words, a delegated authority. These are useful for things like recurring payments. And then we get to smart contracts. So the smart contracts, then you have the application call transactions will trigger the smart contract. And then the smart contract can go ahead and store information on the global state, and then as well as, for example, on a per user basis for local state. So you really have the best of both worlds, where now you can remember stuff, you know, basically right on the blockchain by being stateful. And this really opens the door to really a full-fledged, you know, smart contract capability. We can combine layer 1 features together. For example, here's something very popular in the States right now is the voting with our elections coming up. But you can see here you've got, for example, a scenario where you have a voting commission account up on top. Then you get the spend the voting token. You vote for candidate A, then the voting smart contract kicks in, and then will increment the candidate with a total vote. You can even put a local storage on that to indicate that the candidate has actually voted. Another scenario where you're combining layer 1 features, and this is a crowdfunding account. So you get a lot of crowdfunding, you know, capabilities here by looking at this particular solution. So you have, for example, a stateless smart contract that will have a payment from escrow to user 1. And then once all of the user 1 goes ahead and claims the escrow funds, but not until the the funding is met, the goal that you have, then it is then kicked in and says, okay, now you'll go ahead and get the product or get whatever it is that you're doing some crowdfunding for. So and these are actually a few things that are up on our site. I've got some links for you under the developer site. We have those solutions actually written out. You can take a look at. Get to one of my favorite things here is Indexer V2. This is available through all the SDKs for Go, Java, JavaScript, and Python. And the way it works is you basically have the Algorand blockchain and the Algo process, the daemon, is separate from the indexer process, which really makes sense because you're offloading a lot of this now to a Postgres SQL database, or you can actually choose your own there as far as that goes. And so then that's what the REST API is to that indexer V2 instance that should be doing all your querying again. And so you can search on things like transactions, accounts, and assets, and a lot of filters around the date, the address, balances, signature type, transaction type, asset holdings, asset name, right? So this is what we were talking about before. Show me all the assets that belong, show me all the accounts that have this particular asset. And then also you can look up historical account data for a particular round. Results have pagination, so there are limits to the number of records that turn back, but you can just paginate and loop through and get everything for whatever query you're looking for. There's enriched transaction and account data, so there's a confirmation round, block containing the transaction, the confirmation time, the signature type, the asset ID. Really, you can search just about anything with the indexer on the blockchain. The two steps are, number one, you can build your own, and we have documentation on how to do that. There is also a service that's available, at least one that I know of, PureStake. And actually, that's what I wired up all the demos with. And I'm going to show you on Indexer is I'm going to be talking to the PureStake indexer. So if you do the build your own, that will take several days to populate. Think about it. It's got to go through the entire blockchain. And the service that PureStake provides is really very quick. I mean, I do transactions and I do a query and it instantly picks up information about those transactions. So very, very, very good in terms of giving you complete information and update. Hey, now we got fast catch up, so no more pain at these hackathons that we go to, right? So the problem is catching up from the Genesis block sends the time to productivity, right? You got to wait and wait and wait. For those that have created your own nodes, you know the pain I'm talking about. Nodes create catch points and a secure and downloadable ledger of specific blocks. Basically, every 10,000 blocks, there's a catch point. So really, all you got to sync for is the last portion of the 10,000 blocks that the catch point doesn't get. And I'll show you that in a demo as well. We got rekeying is another thing. So here you got a standard account, but you can authorize another account to do the signing for that that particular account. So again, the private key security policies without operational overhead. So to change a signing key for any account, you had to create a new account. Now you can keep a long-running public address and change the authorized private key as desired. And I got a really cool Python example to show you there. And then we get into more capabilities of it. It's simple. It's a single optional new field on existing transactions for the rekey field. You get a flexible change to a single key or a multi-sig key or stateless smart contract, and it's unlimited. You can change your authorized private keys as frequently as desired. One informational slide on a lot of the reward programs that we have. I know developers are always looking to make money, right? So you got developer rewards programs on this top link. You've got, in fact, let me just, I'm going to escape here. I'm just going to copy these right out and put these in the chat. So you've got these firsthand. And there they are. And also, if you are considering becoming an ambassador, extending our community. There's DevAM's program, and through that you can actually submit tutorials and solutions that will appear on developer.algorand.org, and that'll get you in the program pretty quick. And then also grant programs. You know, some companies are looking at grants to do things like increase, you know, improve SDKs, or, you know, update them, or new SDKs. A lot of different grants are available. And then there is, you know, Ambassador Rewards program itself for, you know, helping out running events like this, and so forth, you know. So nice things there to point out. Hey, developers, let's get going here, right? With the all the tools and the SDKs, and then we've got command line tools as well with Goal. We've got Sandbox, great for quick startup. That's another good way to get started quickly and instantly, you know, is using the Sandbox. And then Catch-up is the second one now, where you can actually do that. And the third one really is using PureStake, because those are all instances that are set up ready to go. Index V2, right? Our REST API querying the blockchain, wallets. We have a Android and iOS mobile wallet, Algo Signer, a new Chrome plugin similar to MetaMask, right, for signing transactions, now available. A lot of community supplied things like Explorers, API services, SDKs, Teal Editor, Debugger, and Algorand Studio. And then here's the link. If you just go out to the Google Chrome Web Store, you can see the link there. Let me go back there. So this is a link that you can just bring up. You can see it right here, and there it is for the link. I'm going to put that link in the window too here for those that like this particular feature. All right, and then sign up for the developer newsletter. Once again, this will get you in the running for $100 Amazon gift card. We'll do the announcement before I get done presenting as to who won. And great newsletter, always showing you the new stuff that's out that week in the developer portal. For those that are brand new to Algorand, there's a few of you out there. Basically, there's these are the networks. You have a beta net, which is where all the new protocols might be tested out by the masses. And then also on the right, you see you've got testnet and mainnet, which mirror each other. The idea is whatever runs in testnet will run exactly the same in mainnet. And then at the bottom, you see something called private networks. I like to consider that more like a personal network that runs right on your machine. I find that useful to create a private network when I'm using BetaNet, because BetaNet kind of goes through a lot of flux, and at least I've got something consistent on my machine to do all my testing with, and then I can go back to the live, you know, protocol versions on the BetaNet. Okay, then also we have open API REST specifications. So these are the files where they're located in the repositories, and you have KMD, which is another daemon that's good for like online wallets. That there you can see the curl command to create that particular file. And then Indexer is its own repository as well, has the same. I think that one there you need to use the open API specification 3. A little bit of a bug at the moment on 2, but you can use either one of these really for the most part. So when you create a node, you can create your own node. Go out to our doc site to get set up on that. You can do it on a Mac, Ubuntu, other Linux distros like a Raspberry Pi. You know, our nodes are so lean and mean that they could actually run on a Raspberry Pi. So think about that. You can actually put sensors, detectors in, and then populate that data back to the blockchain. Again, it used to take several hours to sync, but now fast catch-up is here, not an issue. PureStake API service. It's indexed and archived, and you can access this from any platform. And also now they do have the indexer capability too for V2. Sandbox is actually a Docker. This generally is not used for production. because as soon as you get done with the sandbox and you shut it down or clean it, everything goes away. So it's like kind of like a temporary area. You could point it to mainnet, however, if you did need to analyze something. So mainnet, BetaNet, testnet, all supported with that. And then here's a few of the commands that you do. The way I do it is I just clone the sandbox in the GitHub repository, and then I've got Docker installed already. So then it'll go ahead and I could go ahead and start up my node right there. Developer site has a lot of great resources in the way of documentation. Encourage you to go out there and start building. This is the first steps. You can see your workspace setup, connect to a node, doing your first transaction, building applications as well. Has been added now for the smart contract. So great place to get started. And then solutions. I put up a solution yesterday. I'm building mobile apps, iOS, Android, and Windows using C# .NET SDK. I'm a former Microsoft employee. I did a lot of content over the years, 12 years working for Microsoft. So I'm also a Xamarin certified developer. So I took all those things and I built an example. I know a lot of times you go to hackathons and folks are looking to build iOS. We are looking for folks to build something equivalent in React Native, Kotlin, and Unity 3D would be very big because that would be for gaming. So if anybody's so inclined, again, check out those resources that I posted earlier and take advantage of that. Maybe put a grant proposal together or go through DevM to go ahead and create a solution for that. Articles are up there as well. This is a good one here. This is getting started with Algorand, and then also lots of tutorials. These are all step-by-step, and they all have a code link at the bottom. Some community resources, again, consider becoming an Algorand ambassador. Go ahead and drop an email to Stefan at Algorand Foundation. Again, this is on the Algorand Foundation side of the house, which is the money side of the house. It's a independent company. Eric, Joe, and myself, we all work for Algorand Inc. And so this is, again, a great opportunity. And there's some links on the landing page, a blog. If you want to blog out to a community page, there's at Ecosystem and Algorand and some community events. The C# SDK. And now let's take a look at code demos. And Ryan, I'm going to ask you if you have any questions that we're sharing with everybody and how that's going.
We're going pretty well here, Russ. So we've had lots of early questions about consensus and how pure proof of stake works. There's been some more recent questions about the SDKs, what's provided by Algorand, and what's provided by the community. So we've got some links provided in the chat to that. And now the most recent one is talking about the APIs and how do we get the Swagger definitions and finding out where that's at. So hopefully I'm keeping up.
Oh, wow. That's
very good
into
questions.
My first demo. Look at this.
Yes.
I'm ready to show this. I got Postman up. And so the first thing we're going to talk about is the REST API, as well as, the new version of our SDK and SDKs and REST APIs. So here is, for example, the file that you would download from the GitHub site that I had the link to. Simply, I created import, and I'm going to create a new REST API. I just do the import, and then down here you can actually see the one that just got loaded in right here with 21 requests, and there's the V2 indicator. You've got some new ones in here for compiling T and providing debug information. You got some catch up to do as well. You can call programmatically, so that's pretty cool. And then status and accounts. And all you would need to do at this point would be to go to the edit for that import. Like here, I've got the edit for, I just did this this morning, and I'm going to go ahead and edit it, and then you just go over to your variables and put in your local host. Now that's the local host value for the sandbox that I have running. And basically that's it. So now I can just go ahead and specify in the header, first of all, the token, and then the value. Again, this all A's is the sandbox. And then over on the params here, this is going to get the address. You can see the endpoint. and passing in the address path variable, which I have right here, and I can go ahead and send it, and it'll come back with the information for that. So nice tool. And then there's one for indexer as well. And for the indexer one, what I did was I simply set this to the URL for PureStake. So if I go ahead and edit this, you can see the variable here, and this is my this is the URL for working with the indexer, the IDX2 v2. So that's kind of a quick thing there. And then also now what I'm going to do is show you a very basic demo using v2 and the SDK. So this is going to be from your first transaction. And once again, this gives you kind of the idea of what's going on. Every language is provided here on how to do it. And then there's a link at the bottom for the code I'm about to show you. So let me go ahead and bring that up. And we're going to do this first one in Java. All right, and so the transaction, it's worth pointing out, I've got a couple of routines. One is to connect to the network. This is going to connect to my sandbox. Most of the code has that documented in it. And then what you see here is a wait for confirmation method that we're going to call. So this will actually wait for it to be written out to the blockchain in case you have logic that needs to wait for that. And then also here is an account I already had set up. I'm just going to pass in the passphrase and then regenerate that account from the passphrase. So now I've got an account called My Account, okay? And he's the one who's going to do the signing. And so let me just run this. And we'll hit these breakpoints. And there's the first one. So now I've actually I called these connected to the network. I already got my account set up. Now I've got a receiver I'm going to send a transaction to. This is the new format for V2, right? These are these do a build, and some of the a good number of the SDKs use this approach. Now it's a very clean way to express the statement too, because you can see you've got a sender, you got a note, you got an amount, you got a receiver, because you see exactly what the parameters for and what the value is, right, that you're passing in. So you can just hover over all those. You can actually see we're all set, ready to go with the different accounts. So now I'm just going to go ahead and hit go to the next statement. The next step you would do after you've done the transaction is you need to sign it. And who signs it? My account, right? So that's the one we got the private key for, that we resurrected the account and restored the account to. We can use the sign transaction method. And then down over here, we're going to go ahead and actually do something with the note field, and we're going to do the raw transaction, and we're going to broadcast it now. So this raw TXN method is one that actually sends it out to the network. If there's any problem whatsoever, this is usually the point it would fail. Things like, you know, underspending to an account, and you know, or you know, something else, that the account doesn't exist or whatever. Those are the things that would be done. And you can see now it is actually going to read this response out of the pending transaction information. And now we're going to decode the note field that was populated in there. And you can kind of see this all displayed here at the bottom with hello world being passed in. So good example to get started with. This is the same process you go through pretty much for, you know, a lot of the layer 1 features, whether it's a atomic transfer or it is an ASA file, right, that you're going to be doing. That is something that you can do as well. On the assets, there is one that does everything here, this asset example. And the way this one works is we're going to go and create an asset kind of visually, what I did on the Algodesk site, but this is done with code. So I'm just going to start this up. We'll go ahead and run this, and we'll hit our first breakpoint that we have in the code. And so we're going to go through about 6 steps. One is to create the asset, then we're going to opt in, then we're going to do a transaction, then we're going to, actually the second thing we're going to do is we're going to change the management roles. And then after that, then we'll show you how to freeze an account, do a clawback, and then destroy. So these are all done. So I'm going to go ahead and just hit go. So this is the method call here for asset create transaction builder. Again, make sure you put that .build at the end, and that'll actually execute it here in Java. And then I'm going to hit go here, and then we're going to end up at the next breakpoint, which is to change the manager. But what I want to show you down below here now is the transaction, right? So now here is the creator address right here. So I'm going to copy this, for example. I can go back over to, you know, Postman if I like, and I can put that value in to the parm here for the field name, and then run it, and then you can actually see the asset that's in there. For example, it is there's the asset ID. All right, I can do a little search here for that asset ID, and then okay, and there are the 2 instances. So the first one is the actual creator information. So this has the clawback address, the freeze address, the manager address, and the reserve address all set to, I think that was account number 2 in the example. And then the next instance is the holder, right? This also holds 10,000 of these, and this was the creator, and it is not frozen. So you can actually see the same results here down below in the display. And the next thing I want to show you here is now we're going to change the account. So the accounts, once again, account 1 begins with 7J. The account 2 is one that they're all set to with the AK you saw. Then account 3 begins with this IW. And so what I'm going to do then is just continue executing this. And now what we're going to do is we're going to change the management functions, the manager, to account 1. And so once this transaction executes, then you can see down below now that the manager was indeed changed from the AK account to the 7J account. Then this one here will be the index for the next step is going to be to opt in. So we're going to actually opt in with a special opt-in method call. And now you can see account 3 is the one who's opting in, and the amount that is showing is 0, right? Because we haven't done a transfer yet. And now we're going to actually transfer 10 of these. And I'm going to use this transfer builder method to do that. And so now,
Russell, you're going very fast. So maybe you can explain why do we need to opt in, and what happens if you don't opt in?
What happens if you don't what?
If you don't opt in, maybe like it would be good for the audience. There was some like few questions about it in the chat.
If you don't upend, opt in prevents folks from spamming, right? You just can't blindly send an asset to somebody. That account has got to opt in to receive that particular asset. So account 3 is the one I wanted to transfer to. So account 3 is the one that had to opt in. So hopefully that explains that a little bit more in terms of what that function does. Again, it's all related to anti-spamming. All right.
I think maybe it's also good to say, as like, you know, compared to Ethereum, in Ethereum you can send and forget the asset everywhere, right? You can like dump the asset somewhere in the abyss.
Yeah, you can't just blindly send this asset to anybody. You know, they got to want it. So that's what you have to build in your solution, right? So if you have like a player that is playing a game, as part of their login process, you would have to have an opt-in for that player to receive the tokens in the game, basically. And then while they're playing the game, then you know, you would go ahead and do the transfer of tokens. So moving on here, then this is a freeze function that's available. So I can actually freeze this account 3 to not do any transactions. And again, this has to be done and issued by either the freeze manager or the manager role. And then the manager can also revoke, right, or do a clawback on this particular account. And you can see now down below the status is frozen as true to account 3. And on this particular account, we're going to call back the information. And once this is done, this is going to now see a balance of 0 in account 3. And now the original account 1 has got the all 10,000. And once that's done, then you can go ahead and destroy this. Once you have all the account holdings, destroy is available as an option. So now that is gone. So that's kind of like the whole sequence of everything you might want to do, you know, one, you know, kind of breakpoint at a time. And so that is the examples on Java. So we're going to switch now and to go to our next one. So any questions on that, Ryan, and anything else we got going at this point?
And I don't think that we have any questions related to what you're discussing here, Russ. So I think I'll just have you carry on. We're talking lots about consensus and the verified random function. Opting into smart contracts is what I'm going to talk about next in the chat window. But for what you're focused on here, let's have you keep going.
All right, sounds great. And what I'm going to do here is bring up my sandbox. And this is the sandbox I talked about. So what we're going to show you is how to do fast catch up through Goal. And it looks like it is now available. To my surprise, when I downloaded that latest SDK or latest REST API point, that you can actually do this programmatically now through the SDKs. All right, so I clicked on the catch point link that's on our documentation on this page right here. So this is the page on building an app, Hello World, and this is where you get down to, actually was over here, was in the docs run a node set up install. So this is like your first part. There is a fast catch up section on that documentation. So I just clicked on testnet. I copied off the call, and let me go ahead then and bring up the sandbox, and I'm going to paste that in to my goal command. And we're going to go ahead and paste this into the sandbox to do the catch up. And so I'll paste here. And so this is catching up at this 8897 mark. And I'm going to go ahead and hit this to go. Oh, oops. And oh, I'm in the wrong window here. Sorry about that. Let me bring back the sandbox. That's the one I want to paste in over here. All right, so now we're going to let that roll, and then also there is a command where you can just check the status. And instead of you know, constantly doing a you know, goal node status, there's a watch parameter now where it can update automatically. And then if you go out to the web and bring up you know, any one of the browsers for the, like GoalSeeker, for example, you can see the current block is at 79947. And then you can actually see this updating as it's going through it. And you can see the block number of blocks is downloading, you know, to get to that point. And then you notice the sync time, right? And really, this is the extent of the wait, is really just catching up wherever you're catching it within that 10,000 blocks instead of the entire blockchain. So now this is just such goodness, you know, within a few minutes, this particular endpoint will be caught up. So as soon as you see the sync time getting down to around 0, it will be actually caught up. This is a particularly useful when you go ahead and do a new node, right? And boy, it is just like night and day being able to do that. So I'm going to let that go ahead and get caught up. It'll be done in maybe a minute or two. And in the meantime, we're going to go out to the indexer and take a look at a few of the indexer V2 demos. All right, and so I know we got a lot of JavaScript out there, so we're going to do this one in JavaScript. And let me bring that VS Code window up. And here it is. And let's go over to indexer. Nope, not in Python. I'm going to do JavaScript. So also, I want to note here, for example, if I just want to retrieve an account, for example, what I did was I put in the indexer for PureStake, and which is free access to testnet and betanet. It's a pay service for production. A couple other good reasons for something like PureStake or a stand-up instance that you can do yourself is basically if you are writing a mobile app, for example, you don't have a local host necessarily available to you, and when you deploy it, you want to actually go to a real like URL with a real server running to access nodes in the Algorand blockchain. This will do it for you right here with the server going to in this case, I've got the IDX2 endpoint, which is going to be for indexer. And this is the key that's used for hackathons for them. So I'm just going to go ahead and run this. This is going to be a JavaScript file. So let's go ahead and run this. I have the breakpoint set right in the application. And let me try that again. And there it is right there. So now I'm going to say, okay, I'm going to look for this particular account, and I'm just going to do a lookup and display the information down below. Very simple and very quick, right, when it does that. So now you can see on the debug console, you know, all the information that's associated with that particular account. Then let's take a look at one more here. Maybe account asset ID. So on this one here, we are going to say search accounts for a particular asset ID. So this is exactly the scenario I talked about where you might want to use something like this in building a leaderboard in a game. You want to get everybody else and then, you know, get the results and maybe sort it, right, to get the top 10. Or there is a way you could specify max values and min balances as well as part of your query. I'm going to go ahead and run this then, and we should see this actually come up here with the breakpoint, and there it is. And then now we're going to go ahead and issue that particular information, and then we'll go ahead and take a look at the results here in the console that comes back. So you can see how quick it is as well. There's all the information on those assets. So pretty nice stuff. And then on the you can see you can check against balances, you can look at block info, you can look up applications, right? There's an application Ryan and I worked on the other day. So this is actually a, you know, smart contract. And so I can run this. And then I should do a lookup on that particular ID, that app that we did the other day. So there's all the information on the global state and everything else that that particular application has. Searching by asset name, searching transaction limits, transaction paging. So this will go through and get a page at a time, right? And then there's a next token that's in the response to get, you know, pick up where you left off on your searching. How about this one here? Look at this, search on time. All right, you know, when was that transaction created? You know, are you sure about that? Well, now you have a very easy way to detect this. And now you can see it coming up here as well on this response that's about to display. And there it is. It found that particular transaction I did yesterday at 2:35, you know, in a -5 time zone. So pretty cool stuff on Indexer. Great for building reports, great for utilizing and solutions that you're building to get this information in a very timely manner. All right, so let's take a look at our sandbox here. And looks like, yeah, we are, I'm gonna do we're gonna show you something here too, a new sandbox. You could say clean, right? This will go ahead and take it down. And then do the sandbox up. And then that will go ahead then and get your image up. And it's just that quick. This takes about a minute to run. And then you got some stuff going on there. All right, what's up next here? We are going to show you the rekey demo next. A very, very cool demo. This one here is in Python. And this one here is going to use
Russ,
yep.
Sorry, can we continue with your presentation later, because Pietro is running out of the time and we switched because he was supposed to like come up right after your introduction.
Oh, okay.
So
Pietro, can I have 5 minutes to wrap up here?
Absolutely.
Okay. All right, man. You got it. You got it. I didn't catch that. Sorry about that. We'll take care of that. And so basically what this is going to do, this particular, yep.
What we can do, we can just give a stage to Pietro and then you can finish your demo. How about that?
Oh, we could do that too. Yeah.
Robert, no problem. Let us wrap up and I will take my 10 minutes. Don't worry.
I think it will be better if you can do, because we will also want to have a Q&A session with you.
Yeah.
Okay.
And otherwise we will be just stressed because, you know, you're counting the minutes now.
Okay. So I guess what we'll do then is I will show you this demo on rekeying. And I think what we'll do is after I show you this, the last thing I'll show you after Pietro gets done will be the smart contracts. Fair enough. And this way I can get that all set up, ready to go. And we'll do the drawing. So here we go. We're going to go ahead and fire this up. This is going to be now Python. And so what we're going to do with this, we're going to actually restore 3 accounts. And the idea here is part 1, we're going to rekey from account 3 to allow to sign from account 1. And then the second part of this is we're going to send from account 3 to account 2 and sign from the account 1, which we can do now. So that's the goal that we're going to see here. And so very first thing that you see here is basically I'm going to get suggested params. We're going to go ahead and create our transaction. And then with that, we are going to sign it like you saw in the earlier demos. And then now we're going to read this transaction to confirm it and print it out. So now what you can see here is down below is the information that's associated with this particular transaction. And you can see here's the transaction parameters. We're going to rekey it to the ZL account. And then in the account 3 information, you now see an authorized address to that ZL account. Then I'm going to do the next thing, which is send the payment now from account 3 right to the account, the second account, the VV account. And we're going to use account 1 here is going to be the one that actually is the parameter for the rekey. And so here is the account 1 passphrase. We're going to get the signing. So account 1 is now going to sign. And now there it is. We have the information now down below, and you can see that this transaction was indeed successful, because I transferred that amount, over to the other account. So very easy to do, just really an additional field there. And the last thing I'm going to do here is let Pietro go ahead and talk. And after he gets done, I will do the contest winner. We'll announce that. So once again, if you did not enter the contest yet, all you got to do is sign up for our developer newsletter, and I'll put that in the chat. And I'm going to stop sharing my screen so Pietro can take over. So there you go.
Absolutely. Thank you very much, Russ. I think there were lots of interesting questions. Martinez has other technical questions that probably he's going to be able to mention later on. In the meantime, I probably can take some minutes in order to describe a little bit some elements of adoptions that we are seeing across the boards with some use cases. I can probably share my screen as well. Okay, host disable participant screen sharing, so I'm afraid I cannot do it. Host disable participants share screen sharing.
Oh, maybe you gotta promote him, Robert, to.
If anyone can promote
yeah,
him.
he's not promoted as a co-host. He's got to be co-host to share, I believe. And so, Peter, if you can go to about 10 of, that should be sufficient for me to finish. Okay.
Okay, no problem.
Oh, I don't see. Jean-Marc, are you here? I don't see that option. Can you
Yes.
find Pietro? Can you find Pietro and make him
Pietro, make him a co-host, Pietro, so he can share his screen.
Okay, let me. Petro, huh?
Mm-hmm.
Ah, Pietro.
P-I-E.
Okay, yes, I'm going to co-host. Yes, he is now.
Very, very good. So I can share now my screen. Interesting. Voila. Share. So essentially, the elements, the technical elements that Russ has been describing are actually of use towards a specific aim that Algorand was born for, that is essentially unleashing the value of frictionless economic exchange. The idea of frictionless economic exchange has a lot to do with the characteristic of scalability, decentralization, and as well security, cryptographic security that are at the basis of the creation and the founding of Algorand from the side of Silvio Micheli and his own team. The fact of giving enterprise speed, advanced cryptographic security, efficiency, and ease of use in the various characteristics. So to be able to bring, I would say, frictionless economic exchange innovation. Finance is probably just one part of what can be done and what can be conceived in terms of business model with Algorand. And by the way, Algorand allows a lot of combinations of what you would call real economy and finance and vice versa. Therefore, the ability to bridge a little bit the gap between the two areas. I would say, okay, this is the team. We've been talking about how delegated proof of stake, bonded proof of stake, and proof of work have intrinsic limits that with pure proof of stake consensus mechanism, we try to overcome. And these are the elements I was referring to before and that actually set us apart. On Slido, someone was asking, the exact question was how Algorand with Take Ethereum place in decentralized finance, which is an area that we can talk about, but more generally in economic exchange. And the answer is through these elements, scalability, cost effectiveness. Of course, you cannot compare a logic of thousands of dollar per transaction as a cost compared to $14 of gas cost. These elements can also be implemented both in the public and permissionless side and as a private instance. By the way, we have plans to bridge the two worlds, like in real life, public and private coexist. We have our own privacy, our own private persona, and we have as well a public persona that during the day we tend to swap multiple times. This is going to happen in blockchains as well. The economic environment, the ecosystem that has been created around Algorand in little more than 1 year of existence of the public protocol is pretty interesting. And I can focus on a few areas of adoption. The ease of tokenization that Algorand allows to put in place has been appreciated by multiple types of economic agents. First of all, let's think for a second what tokenization means. Tokenization is a digital representation of anything that you want to call as an asset, right? And digital representation without the risk of double spending, which is the specificity of the blockchain. That's the very reason for blockchain was born. So we have this infrastructure that allows an easy, immediate, as Russ has been showing, ability to digitally represent something that cannot be double spent and remains in the records, in the ledger, and cannot be tampered. What can we do with that? Multiple things. We have people specialized in asset tokenization, so primary issuances of equity, for instance, like it's the case of Republic that does crowdfunding and equity and tokenizes all this through Algorand. We have people tokenizing in specific jurisdiction, real estate, in order to be able to exchange them without friction and with fractionalities that otherwise would not be possible. We have the World Chess Organization that is essentially doing an hybrid IPO, first on the blockchain with us, and then on the small medium enterprises segment with the London Stock Exchange. I would say that in the area of asset tokenization, it's not mentioned here, but I like to mention the use case of PlanetWatch. PlanetWatch, by the way, interestingly enough, the legal entity is based in Saint-Genis-Pouilly, which is probably just a couple of kilometers out of Geneva, right? In the French territory. So one might ask himself, why in France and not in Switzerland? PlanetWatch is actually a CERN spin-off, which has as a business model, they provide sensors for the quality of the air. These sensors are fixed sensors, mobile sensors, and also wearable sensors. And essentially they created the tokenization of, apart from sending the air quality data to the tamper-proof ledger of Algorand, they also want to incentivize the adoption of a behavior from their own clients. And that behavior is actually to create the data about the air quality, right? So they incentivize this through a token. So they essentially tokenize the fact of providing this data. And essentially they, in this way, they tokenize a specific asset, which is a data that is valuable for citizens, for public authorities, also for companies that want to know how much they are polluted. We have other clients that are actually in other areas of the value chain in terms of digital financial infrastructure. We have clients like Stone Eyes that does securitization of account receivables in Italy, in Rome, with the public administration. So though securitization exists on paper, there are specific protocols that have been created in the various regulation when it comes to securitization. We are not inventing securitization with the blockchain. But doing securitization of account receivables on a blockchain allows Stone Eyes to provide their own clients that are hedge funds, that are institutional investors, a level of transparency, a level of traceability of the asset up to the single invoice that actually I would have dreamed of during the crisis of 2007, 2008, which was exactly a crisis where the lack of traceability of the actual evolution of an asset, which is not necessarily born rotten, but becomes rotten, becomes non-performing through time, was exactly the cause of a contagion effect. I think that this use case is particularly interesting because it does pari passu, in parallel, the usual regulated procedures on paper for securitization, but enhances the service that is given to clients through the transparency and traceability that comes with the blockchain. And by the way, a blockchain that does truly atomic transactions. It essentially does transactions that happen on an all or nothing basis without the need of a third party, a custodian, or an hash time lock, which is always subject to denial of service attack. We have other cases like Monerium that creates e-money in a licensed manner. They are based in Iceland, but they can provide this service in multiple jurisdictions, UK, Sweden, and the Eurozone as well. People that are doing payment infrastructure based on Algorand, like Bleumi. And we are active as well in the areas of stable coins and central bank digital currency. You know that there is a lot of interest for central bank digital currencies. Legal tenders and central banks understood that blockchain represents a technology that, again, avoids double spending without the central point of failure risk, so they can still be a central bank with a different infrastructure, and therefore are exploring this. We actually did already a central bank digital currency with the first sovereign Marshall Island currency, and we are participating to other RFPs and other tenders. We are also, as Russ mentioned before, and working on various types of stable coins like Tether, USDC. Again, the real point is that the various use cases that we are talking about here, we have as well the use case of CI in Rome that uses Algorand's blockchain for copyright management, are actually leveraging the features that I will mention just to close my intervention here. The Algorand standard assets, the logic of truly atomic transfer, and the smart contracts in layer 1. So at the end of the day, we think that we have a technological stack that is more performant, that is more secure, that is actually true to the decentralization logic that is typical of the blockchain. That's how we will win this sort of competition. I don't know if there are questions at this stage. Otherwise, I would give the virtual microphone back to Russ.
Great.
So let's like have this like 5 minutes, a little bit of like kickoff here about like seeing how Algorand solves some business problems.
Okay.
And Russ, feel free to chime in and like also help with the answers and maybe like follow up on some questions. So let me start. So recently there was this big event related to Republic. So could you guys say a few words about what's Republic, why it was so important, and why they chose Algorand, and if you know anything, if they were considering other options. So here in Europe, I think we less heard about Republic, but I think it's probably one of the unicorns in the Silicon Valley, isn't it?
Yeah. I believe we've got a use case on our site. I'll go check that.
So Pietro, could you comment on it? So
yes,
what's Republic?
Sure.
What's Republic? What was so important? And
sorry, I'm losing a little bit the line here. Republic does actually equity fundraising through the blockchain. Let's put it this way, right? And what they needed was an infrastructure. Sorry, I am sharing the screen of my LinkedIn, I suspect. I got to stop the screen sharing.
Don't worry, it was a presentation.
Good.
Here it is. I can share.
Fantastic. So Republic was looking for a platform that was able to tokenize with ease. I think that Russ has been showing the ability that through algodesk.io or in other ways, Algorand can put at disposal of any kind of developer, right? Moreover, I think that they've been putting in place a specific security, which, if I'm not mistaken, was a bond that has been launched through Algorand blockchain. Again, the finality of a transaction and a block in 4.3 seconds is not something that you are able to have elsewhere. So this was the real reason, as far as I know.
Yep, I put a link in the chat window for our use case about Republic on our website, so you can read that as well.
Yeah. Again, it was born for crowdfunding, then for equity fundraising, and it's a regulated entity. It's something that actually has value, makes a lot of sense from our side to partner with them, and they actually can leverage fully the characteristics of Algorand. You want for this sort of digital representation of an asset, a blockchain that actually scales to millions of users. We had recently an interesting use case here, which was the onboarding of Props. Props does loyalty points, which is not an invention. Actually, the point is that they actually create a common denominator for the various loyalty points programs that one might have. So in my wallet, the physical one, I mean, I have probably 6 to 8 different cards for different loyalty points, the supermarket, the car sharing, the airline, Alitalia, and so on and so forth, right? And at the end of the day, you have this situation where they created a common denominator so that you can exchange one with the other, millions of users. We've been onboarding them, a couple of millions of users, and transactions moved above the 1.6 millions in 24 hours. And the speed of finalization of the block didn't have any glitch. It remained around 4.3, 4.4 seconds, right? This is what you call scalability.
All right, if I can I show my last 2 demos here and then we can continue with questions? This will be quick.
Sure, I'm depending on Pietro. Pietro, do you have like a few minutes
Absolutely.
more?
No, that's fine for me. I saw an interesting note from Jean-Marc Seigneur about T2 and CBDC standardization working group. I would be very happy to liaise with you, Jean-Marc.
Okay, great. So we can like exchange emails about that, and
En plus, je suis francophone, donc.
Yes, okay. So it's even better.
Great.
Okay, good.
So because Pietro will be leaving us, so is there any other question for Pietro? Okay, with that, he left his email, so he can answer the questions.
Right, thanks. Yeah, I put mine in there as well, and Ryan too. So we'll be happy to follow up with y'all after this session.
It's maybe also to Pietro, I think you forgot to make the introduction. Yes, you are the business director in Europe of Algorand.
Right.
Right. So you are perfectly the right person.
Thank you. We do it at the very end. Thank you, everybody. It was a great pleasure. Bye-bye.
Great. So we're going to show you the contract account, which is basically the stateless version of our smart contracts. You can see here, I'm just going to load in this sample program, which is a very simple program. It just takes an argument and compares it to the value of 1, 2, 3. If that's equal, it returns back true. The thing I want to point out here after I load the source is a new compile option in the SDK, so now I can compile inline the source code that you can see in the listed on the hovering over here. So we'll go ahead and run through that. And then this is where I'm going to actually pass in a parameter that you can see down below with the 1, 2, 3 value going in as an argument to create the LSIG. And so what this does is basically when it goes to run this transaction, this payment, we're going to go ahead and do that. But then what we want to do is take a look at the LSIG right here, which is the logic sig transaction, using that LSIG, which has the program in it that will return true. And so long as that returns true, everything will go ahead and just run right through, and you can see down below that the transaction was indeed successful, that it actually did transfer that amount. The other one that's in here is the one for account delegation. It basically does the same thing with one difference, and that is we want to get the signing key from an account that's going to sign off on it, and we do that right here. So we're going to get the signing key right here from this account we're going to be recreating, and then you can see you've got the address of the private key that we're going to use, as well as coming down here to actually sign it now with that LSIG. And then it's the same process. We just go ahead and create the payment transaction, send out the logic sig. So as long as it's signed and the value comes back as true, you're good to go. And so this one here, we'll go ahead and just run right through that. And so now you can see this is going to be successful as well on that one. The final demo, I like to build things up to a crescendo. This is actually hot off the metal here, the stateful compile. And let me start out with just scrolling down this a little bit, what we're going to accomplish here. We've got a creator account that's going to be one of our accounts, and the other is going to be the user account. The user account is where we're going to store the local storage. And the first thing you want to do is declare application state storage, which is immutable. And then this is, we have inline the program that's going to be run here, the smart contract. You could read it in if you want, but we thought for clarity it'd be good just to include it all in line here. And this is the initial source. So basically what we're going to do is go ahead and do our opt-in, like we had some questions on here, as well as do the update. But then right down here is where we really start getting into the business, where we're going to check for the creator with a creator address, and then we're going to do a transaction. And then here's where you want to read the global state by doing a get app global state get. We're going to go ahead and increment that value, and then we're going to go ahead and put it out and store it to global state. And then similarly, we're going to read the local state for the sender, and you can see right here we've got the initialize the counter. We're going to increment 1, store that into it as well, and then this is the local state, which will get stored. And then finally, we're going to go ahead and load the approval value. And there's a label here to go ahead and close out, as well as delete the app or do an update. There is a second program we're going to step through, which is exactly the same thing. It's going to be an update, except there is one new feature, which is writing a timestamp out right here. So these few lines is really the only difference that's going to be there. So what we're going to do here is I've got some routines here with the compile, like you saw, getting the private key, waiting for the transactions. I'm just going to go right down to the main line, and we are going to hit our first breakpoint, and we can go through and step through the code that processes this. So let's go ahead and run this, and we come down to go ahead and create the app. And this is a routine here. This is the create app routine. And we're going to go ahead and first do the application create transaction. And you can see the sender is the NI account. And we then got our PARMs and on complete and approval programs. Oh, there's a clear program up there, which is just an int 0. That's right at the end. These right there. All right, so that's our clear program. And then you can see the signing the transactions and sending it out and waiting for the confirmation, just like we've seen in the other example. So I'm just going to hit run here. And you should see a print of the new application ID down below upon success right after it. So there it is. You can actually copy that and go search on that in the one of the explorers if you like. Now we're going to opt into the application. So this is going to be the user, right, that's going to do this. And there was a question about this in the chat window. So we're going to go ahead and do this opt-in transaction in that method. And so that's it for this one. So now he's going to be opted in. And then once it's complete, come back over to the main line. And what we'll see is the next step in the process is going to be call the application without arguments. Okay, so this is different from where we're going to go at down the road here. We are actually going to pass in arguments, which is going to be related to this this timestamp, right, that we have there. All right, so initially we're going to use the original program. I'm going to go ahead and now we got the no op transaction to go ahead and sign, go ahead and opt in. And then what we got to do is we're going to read the local state here from the user's account. And there it is. We're going to go ahead and just do pull the application local state out, and then we can get the application and then the value. All right, so you should see those print out down below over here. And so now you can see that we've got like a counter of 1, for example, down here as well. All right, now we're going to read the global state back. So this does just the opposite, right? It's going to go ahead and read that the global state that we have, and as opposed to the local state. And then we're going to now update the application with the application that has the new timestamp in here. So that's the update application update method. And we will go ahead and do the update now with that. And once we get the confirmation back, we should see that that has successfully executed. And there it is. Now we've got that as well. We're going to go ahead and continue that with the same process that we did before. Opt in, and then we can see here we've got the next thing, which is going to be calling the application with the arguments down below. First, we're going to go ahead and read this local state. We're going to close out the app. And there's the closeout, and then we're going to go ahead and then bring up the second application now to go ahead and do that opt-in. And then come down to the next step, which would be to actually utilize the new one with the args in it. Okay, so now you can see there is the timestamp, for example, we're going to add in. So now let's go ahead and read that local state once again, and we should see the information updated there in the local state down below. All right, and then you'll actually see that displayed for this particular app ID, and you can see the all the information there associated with that. Finally, we're going to go ahead and delete the app, and this will go ahead and use the application delete. And now this guy has gone full circle, and we've done the complete process of most of the things that you would want to do from an SDK perspective. And the final step will be to clear the app. So that will clear it from the user account storage. And that is it. I think what I'm going to do now is go ahead and do the drawing, and as soon as I summarize here. So basically, what we saw here is, you know, Algorand's many features. I think, you know, really the big thing here is our pure proof of stake and how quick it is and how much it scales. We looked at all the layer 1 features, including Algorand standard transactions, atomic transactions, as well as smart contracts. A lot of new features: fast catch up, killer, rekeying, killer, index v2, killer. Looked at a lot of the reward programs Foundation is offering up. We'll get you all the links on those, developer tools, community resources, and a lot of code. I'm going to leave this slide up, and if you want to, please do a quick eval for me. I would greatly appreciate it. And I will also stick that into the channel here for a survey. Okay, and here it is. I'm going to copy this and paste this in here. And one of the questions is, what are the incentives for running a node? You actually get rewards, and if you get selected in the voting process, you would gain rewards on that as well. And Ryan also posted in there our proof of stake consensus protocol for those that are fairly new to our blockchain. So I'm going to go back over to here. I'm going to do the drawing now, and let's see who the winner is. We've got to go with
you should use the VRF for
yeah, no, I've got it. I've got it right here. All right, so randomly picking, the winner is Patrick Woleb. Are you online, Patrick?
Yes, I'm online.
Hey, great. I'm going to send you I'm going to copy your email just to make sure send it to you privately, Patrick. Where are you? I don't see you on the list. What's your name on the list?
I'm on the ambassador program. Does that still count?
That's fine. That's fine. That's good. We got, I don't see you on here. P-A-T.
Or maybe Patrick, maybe you can contact Russ directly.
What's your name on the meeting here?
I don't know. I didn't put my name, so it could be
okay.
Might be Phoenix Rising, but it could be Patrick Woleb. This is me.
Okay, your email I've got is patrick.woleb+rand@yourdomain. Is that accurate?
Correct, yeah.
All right, good. I will send you a link shortly with your gift card. Thank you very much, everybody.
Okay.
I'll hang out for a little bit for any additional questions. And I really do appreciate you having us here to present this topic here today. Hopefully everybody got something out of it.
So the time is like running, and we still can do a few questions, and then like the last part is about 20 minutes to demo and show you the beta release of Algorand Builder. Does anyone have any question?
Yes, I do have a question. So when you read local state, is that a transaction you still have to put, is that a chargeable transaction?
No, so I'll take that one. If you want to read from the blockchain, that is not a transaction. That's simply an API call. So you can read from any API node that you would like.
I'm reading state though. That's
right, but the state is stored on the blockchain. It's again, it would not be a transaction that you are presenting for validation. You're making an API call to get that.
Okay, cool.
I may enhance a little bit on that. So yes, if you are running your own node, yes, then you have all of it, so you don't pay anything. However, if you are using some node as a service, let's say PureStake, they will limit you by amount of the API calls you can do. Right, so you have some free tier. I don't remember. Probably you have like a few thousand API calls per week or whatever, or a month. And if you reach that threshold, then you will need to pay for that calls.
Okay.
I did want to show you guys one really great document on getting set up here with, where was it? Over here, I think.
Do we have some additional questions while you look for that?
Yeah, anybody else?
I mean,
There it is. I wanted to show you guys this. This is the migration guide, API v2 migration guide. And actually, Ryan did this page. It's really great. It shows you how to install the SDKs. How do you check for the version number after you installed it? I think we're up to 1.7 now. And then also, you know, what the V1 is going to be deprecated. I mean, we're still supporting it for a while, but you really want to start using V2. It's more feature rich. And then these are the client instantiations for each language. This is how you get up and going with both the client, LOD client, and the indexer. Then you got the Python information down below, and you know, for Java, and also for Go. So those, I just wanted to make sure I showed you those here today.
I may maybe only add a little bit that related to the TIL code, yes, the Ras was showing to you, it might look a little bit low level, but there is a Python wrapper, and you can write a smart contract in a Python and then compile it down to TIL.
Yeah, the PyTeal is really great.
If you are browsing,
we actually have an article written on that in our, you know, just do a search on PyTeal on our portal, developer portal. So this is a great article she wrote out on using PyTeal, and great you know, example on that. So that's a good one to kind of read through as well. All right, cool.
I've got one more question. Is there any means to encrypt state?
You mean the blockchain state, like the state which you share between different people?
Yeah, local or global state.
I am not sure on that one. I would lean toward yes, to be able to encrypt and decrypt it the way you want to, similar to what you can do with the note field. I don't know, Ryan, if you have a definitive answer on that or not.
Yeah, the state itself is going to be public. Obviously, you have to be able to read it to get the consensus, so we store it. But then, if you want to encrypt the data that is being stored, you can do that. And then, if your application or per user basis, if you are providing a mechanism to decrypt that information, you could do that, but that would not be provided, if you will, out of the box.
Yes, so on the smart contract or whatever in a transaction, when you send the data, yes, you can encrypt that data, and then the DApp, if the DApp knows how to decrypt it, yes, then the DApp can just read the data and do whatever
Yes.
Whatever
Yes.
they can.
That's technically possible, yes.
Any last question? If not, we are wrapping up here and going to the hands-on. All right, so Ras, I hope you will stay and see. I will do a little bit of the comparison about the API calls. We appreciate if you can stay here and maybe also ask questions there.
Yeah, I can hang out for a few more minutes, then I got to get to one more meeting. But yeah, I'll be happy to.
Okay, so let me share the screen.
All right, I'll stop.
All right. So I'm going to present the Algorand builder. One second, just find my website. This way. Where is this thing? Sorry. It's here. So this is the repository. I will share it later with everyone. I want to very quickly only have like around what's in this repository. So Algorand, oh no, that's not this one. Sorry, that was the Algorand SDK. So the Algorand builder is a TypeScript package. Think about it as a truffle for Algorand, and it allows you to create assets, deploy smart contracts, do some script execution in a very highly managed manner. So the main features is that you have a DSL for defining the assets and deploying them. We introduced a concept of the checkpoints. A checkpoint is that whenever you deploy an asset or a smart contract, we will store information about it. So you don't need to go and let's say browse the transactions using the Explorer. You can quickly go back and see when and who created such a transaction without using the Explorer. So the package, oh, by the way, let me firstly start with a shout out to all the contributors. So Martinas is here with me. Amit recently joined, and Amarusha, she was here with us only for a few days. So everything is in the TypeScript. Maybe very important is that the whole package, in fact, it's a Yarn workspace. So it's a mono repository with multiple packages. So to start up, later on after this hands-on session, I'm going to invite you to see and read the README file. You also have the spec doc. In the spec doc, you have like the whole overview of the components. How does it function under the hood? What are these checkpoints, and so on. I will not go there right now. Instead, I will focus what's how to use it and what are the packages. So like I mentioned, it's a monorepo. For the moment, we have two packages. One is the TypeScript typings. So Ras was showing you a few SDKs. One of them is JavaScript SDK. The JavaScript SDK is lacking the TypeScript definition files, type definition files. So this is what we started on. We took the initiative and we created, it's still evolving. Not everything is there, but let's say all the major functions are already there. We still need to clean some any types and so on. So if you would like to build a project with Algorand SDK in JavaScript and you want to do it on a TypeScript, then go there and fetch this package. It will help you a lot. And then the principal package is this AlgoB. So AlgoB, basically, it's a truffle for Algorand. Okay, so let's move on. I will now show you in action how does it work. But firstly, I want to show you how to start and run an Algorand node. So the agenda is following. We will run the private node, and then we'll use that node to deploy assets. In the email I sent today by morning, you have the instructions how to download, how to install the Algorand node. So we will not go there. So I assume the algod command is already there. Okay, so this is the pre-requirement. There are multiple ways how you can create a local network. Ras was mentioning about Docker. Yes, you can install the package. So here we will use directly the algod command. Algod is Algorand daemon. It's responsible for running the node. What you can do here, so we can create, so Algorand D has a way how he can also manage the whole network, like a small network, yes, of nodes. So the first step is to create this network template file. The network template file will specify as the network name, what are the nodes participating in this local network setup, and the wallets and the stake. So in the wallets, we can define like few wallets. It will be like so each of these wallets will have the initial, let's say, Algorand supply stake or partition. So here in this example, I have only one node and one wallet. So the wallet one, he will receive 100% of the Algorand supply or Algo token supply. I can add more. I can, let's say, then split it down for 30%, 30%, and 40% if I wish. Yes, but then it will run 3 nodes. And for development perspective, if you don't test the consensus protocol, this doesn't make any sense to use it. So by the way, I will share all these files after that, so you can repeat it. So when we have this network template file, we can go and start a network. So I also have the make file here, which will help me to run these commands. Oh, by the way, this is the link from where you can see how to install the node. So I'm going to create a new node, set up a new node, and set up a new private network. So yes, here is this network. By the way, so there's a special command goal. When you install Algorand, Algorand package will offer you a few commands. So this algod, it's goal, and kmd. Algod is for managing the node. KMD is a key management daemon, and goal is a CLI for interacting with the Algorand node. So in fact, it offers you all the functionality of the SDK. You can create an account, you can send algos, send assets, create a smart contract. You can do everything. All right, so the node was created. How can I minimize it? Okay, no. And here is this directory, node data. If I open what's in the node data, yes, you will see that there is this primary node, which is the node data, and then there is the participation key, root key, the genesis file, and the network file. So let me open node data, the genesis file. Here you will see that, okay, there are 2 addresses with the rewards pool and the sync pool and the wallet. So this is the wallet which was generated for me. The rewards pool and the fee sync, those are special addresses which are used to collect fees and to collect rewards. So rewards is rewards is not to collect, to distribute rewards. So when you participate in the consensus protocol, whenever you create a new block, you have a reward for that. And the opposite, when you create a transaction, you need to pay for it, and these fees are going to this fee sync account. Okay. So let's start the node. So I have this command, make start private. So the network is started. And now I can type goal. So again, goal is the CLI for the Algorand node. So go network. Network. So those are the commands we have. We don't need to use this create, delete, and so on, because we already did it before, and the goal is managing for this for us. So gold network status. Oh, sorry. Oh, yeah, a very important thing. I need to export, or I need to inform what's. I need to tell to goal command where my node is operating. So I'm just exporting this environment variable. Other way to do it, I could use a command line parameter d. But since we will use it more often, I'm just going to export the environment variable. Okay, now go network status. Oh, oops. Does it work? Mm-hmm. Oh, okay. Let's do this way. Oh, no. I didn't understand. Oh, no. Okay, let me do it with D then. D node data. Oh, what's that? Oh, sorry. Yes.
Back up one directory. There you go.
Okay, yes. Here we go. Thanks. All right, yes, because Gold Network will need to operate one level up on the network directory, not on the node directory. So here we see that the blockchain is operating. Here we see the last consensus, the last round, and so on. The next step, okay, here I have some sheet I would like to follow. So my demo steps. Okay, goal and node status, we already did it. Now we can go to the node status. So now since we exported the Algorand directory correctly, so this one expects the primary node, we don't need to put the -d anymore. I'm going to list the accounts. And this is the wallet account, the major account. And as you see, it has the total algo supply. If I'm not mistaken, that should be something like 100 millions, something like that, algos. But it's written in micro algos. So whenever we do a transaction, the base unit is micro algo. So 1 million micro algos makes 1 algo. I will need one new account. So let me create account new. Okay, and now I want to send. So let me copy from here. I want to transfer some algos. So let's say from this master account, which is this one. So this is what we call the master account. Master account is an account which has some algos which is used in the Genesis. Oops, not here. Here to the new account. So this is the new account I created. And that's something very nice in Algorand. Every transaction, every single transaction you do can have a node field. So think about this as a reference field. I found it very, very useful, especially for the compliance reason, because I can link, I can attach any data to a transaction. This is something that doesn't exist in Ethereum, for example. So I'm going to send 123 algos. So it's 133 algos, it's 133 millions of micro algos. That's why this big number here. Okay, so let's send. Let's wait a little bit. So here it uses the default fee and default parameters. Okay. Oh. Oh.
Maybe cancel that. Do your status one more time, just to make sure it's advancing.
I think it's. I'm trying to run it from the. Let me stop sharing here, and I will share the whole screen because I think the Emacs console session doesn't support that well. Okay, so let's go here. I'll go Role account list. Oh, I need to again export the right. Parameter. Oh no, what I'm doing here? Ah, sorry. Again, wrong directory. No. Right. So, okay, so we have this new account here generated, and okay. Well, okay. Oh, oh, do we have it? Yes. So let me do again the transfer. Let me go node status. Okay, so we have it. So from I want to go from this one, this account. So this account, this is the one from Genesis.
I don't think the blockchain is advancing. It says last committed block 0.
Why not?
I'm not sure either.
It's not good.
I did this demo like literally half an hour ago and was working.
Oh, of course.
Maybe do a do gold network restart -R.
And I need to do the root, right?
Network restart.
Yeah.
Then yeah, -R, and then the root. Yeah. Let's see what the status says this time. But it should have responded. It should have said. It should have said restarted.
Okay, so let
or
me
started node.
remove the whole node data and let's start again. Make create private. Make start. Make start private. Okay. Is it syncing? Okay, last block committed. Yes,
That looks
now it's
better.
advancing. Okay, so here we see that. Okay, we already have block 3. Okay, so account new. Oh, sorry, goal account new. Goal account list. Yes, now it's much faster, much better. So we see the new account. Let me copy it from here. Now I'm sending the algos. And by the way, while we are using it, because we will use it in a next demo. So I want to go from this account, correct? To that account. Oh no, so I didn't copy it. Oops. So this is 2. Oh no, I didn't copy it correctly. Okay. Like this. Is it correct? Okay, yes. Yeah, this is bad. Wrong accounts. Oh no. Add request.
No, they're the same account. I think maybe the 2.
Yes.
The 2 is not.
Yeah, didn't copy it. So I need to do the 2 is bad. Correct. Thanks. Demo effect. What? Okay. I said that I don't. Or. Oh yes, sorry. This is bad. To the account and from is here. Okay, here we go. And now when I do the list, I can see that here we go. We have the algos received. Okay. So maybe one very last thing about a goal. You can have this. You have this asset command. With asset command, you can create the assets. So asset essentially it's a token, right? You can create a token, send it, and manage it. Now I will go directly to the Algorand builder. So here we go. We are still creating. Okay, so that's a beta release, and if you want to follow it, you need to clone the repository. We still didn't release the. We had like some issue on the GitHub side. We didn't push the package, so you need to like build and compile the package yourself. It's very simple. So you need to basically clone the repository, go to the root, which is here. Do yarn install. So I already did it, so it's very fast. Then we need to go to the package, algo-b package, and do yarn link. So what yarn link is doing is adding that package, it's registering the package into our local yarn repository. Then I'm having this example. So in the package itself, sorry, in the repository, if you open it, you have the examples directory. So what I did, I just copied on a site, and I'm having it here. So the first thing you need to do when opening the example, we need to check the config file. It's algo-b config. And here we prepared like a config for you. So in a config file, you need to define what accounts you are using. You need to specify the network and access to the network. Let me go back here. Let's see. Okay, so if you want to see what is the access or how to access your node, you go to node directory, the node itself, and there are two files. There are algod.net and algod.token. So the .net will show you on which address it's operating, and the token is authorization token. You can change the network address in the config file of the node. So make sure, so here we have our default configuration. Now we need to make sure that the host port is the same. Here, since it's a new network, of course, the token is not this, it's different. So I'm going to copy it to the config and have it here, putting it here. So the config file is in fact the JavaScript file. We can run functions here. We can import files, other files, all the JavaScript files for here. But the thing what we need to export is a map of the networks. Each network specifies like I said, the credentials and also a list of the accounts. So how we can provide the account list? There are a few ways how we can do it. Oh, by the way, so what's an account? Account has a name and description of the account. First way is, okay, we can provide a mnemonic address. Second way, we can provide a private key directly. Third way, we can import it from a file. So there is an import. So here are a few examples. I will not go through it, but yes, you can import it from the file. And the last way, okay, not the last way. The last way you can have it from your environment. So if you want to keep your credentials very secure and you are in the production, this is probably how I would like to do it. So either from environment variable, you can read it using the JavaScript, of course, or using the KMD. So remember at the beginning, I mentioned that Algorand package provides three binaries, AlgoD, KMD, and goal. And KMD is in fact this a secure software which will protect and store the keys for you. So this is what you can do with the config here. Okay, so I have what accounts do I have here? I have a master account. So the master account is the account which I will use to create new accounts to create an assets. Remember that for every transaction we need to pay, so this account has to have some algos there. When we create an account, if the account
I got to head out. I got a meeting at 2:30. So thanks a lot, man. It's been a pleasure.
Thanks, Russ.
Okay, bye-bye.
Thanks for having you.
This is Patrick again. I gave you the wrong email. Sorry.
Oh boy. Send it to me in the chat privately, and I'll do that.
As well. Thanks. Sorry about that.
So here for the master account, I will use the account we just generated. So again, I'll go account list. It's this one. So let me copy it. I will put it here. And here are the few other accounts we created for the demo purposes. So the basic pattern is that you don't want to store here any mnemonic and the private key which you will use in the production. Yes, you can use some test mnemonics or test private keys here, something that you can use, you can share with everyone. Okay, so we have the master account, and in the script, what we will do, we will create two assets. We will create a gold and Elon Musk shares, Tesla shares. And correspondingly, there will be stored by these accounts, the gold owner account and the Elon Musk account. And to make these accounts active, we will need to send some algos there. Okay, but step by step. There is one more interesting feature. Oh, so what we need, so okay, let's go here now to the builder. Oh, no, to the example. So here we have this example project. Like I mentioned, yes, it has to have algo.b config file. So now we need to run, to link it with the Algorand builder project. So what I need to do, I will do this, yarn link, so algo.b. It's successfully linked. Now I need to install all the dependencies. And now I can run algo.b. Since this is linked, I need to be in the yarn context. So let me only show you this package. I added here like a shortcut how to run the algo.b. So we have this yarn run algo.b. Sorry, one more thing. Here we have an exception because whenever we load the data, we do validity checks. So this public key doesn't correspond to this mnemonic. Since we will do operations, we will need to be able to sign it. Knowing the address is not enough to sign the transaction. We need to have a private key, but I didn't change the private key here. So I need to export the private key. So I have my notes here, and this is how we will do it. Okay, it's basically here. Go, count, export. And I think I need to use this one. And it's this address like that. Okay, so now I know my mnemonic. I'm copying it here, and I'm pasting it in the config file. It's here. Okay, so let's go back to our example. Wow, now it works. By the way, if you are starting a fresh command, we can write init. The init will generate you, it's like, it will generate you a new project, but here we already are in the project, so the init will not work. If we create a new temporal directory, oh yes, sorry. Why is he? Sorry. Yes, it detects that he's already in the Algorand project, so I would need to go into the other context. Anyway, but important thing is that we have this Algorand config file, algob config file. So what we can do here? Let's algob. So let's see what options do we have. So we can clean the project, we can compile the smart contracts, we can run the console. It's basically a JavaScript console. We can deploy, generate accounts, help. This is what you see in it, and do a node info. Let's check the node info. We'll see if you are connected to the right node. Algob. Voila. Should be the same. Okay, like the next version, last version. Here we have like all the network information. So this is from the config file. And this should be more or less what we could see here when we do make status. So the next rank here is 2013. Here is 2007, yes, because a few runs already passed in the meantime.
Robert, can I ask a question?
Yes.
So did I understand correctly? You had to create some accounts up front in the network as well.
So,
so did it create, for example, the Elon Musk account? Did it create that through Algorand?
No, not yet. Not yet. Okay. So so here I'm specifying the accounts I would like to use.
Mm-hmm.
This account, the Elon Musk account, doesn't exist yet on the blockchain because we didn't use it. It's just I provided the private key for it and the name. Okay, so mnemonic. Mnemonic is so what's mnemonic? Mnemonic is a list. It's a sequence of strings. I think 20 or 22 words, which get translated to the private key. And the thing is that whenever you want to use that account, you will need to found it. So you always need to have an account which is founded, which is active. So how to get this account? How to make it? So you need to, if you operate on a local node, this is why we had these previous steps here. Yes, we created a new account like that. Sort of with the algob, with Go, and we sent. So with this account, with this command, we sent algos from the account which already is active, which had and still has Algorand tokens to the new account we generated. Yeah, so you see, this is the account we previously generated with Go account new.
Mm-hmm.
And account list, let's put it this way. Right, so it's this one, right? And
account. Okay.
and we found it. The master account is this. Yeah, sorry. Yeah, the master account I'm using. So the name of the master account is just account which is already active.
Yeah. Okay.
Or which I will use to do anything else. So as you will see, I will show you in the script. We will later on activate these two other accounts by sending the algos there, as we did here with the goal command. And then we will create assets. Okay, so let's go back to the algob. So algob is this new command. Sorry, our project Algorand builder. One other interesting command I would like to share with you is this algo-b generate accounts. Oh, and it expects like the number of accounts I want to generate. So let's say 4. So if you don't want to go into SDK, into some tools, and you just want to generate accounts, like something that you will use here. This is in fact what we did here, yes? You can just generate them, and it will create this file in assets directory, accounts generated. So let's check it up. Assets, accounts generated. And it generated for us these accounts. I can swap it, I can, let's say, do more or 6. Oh, I think I will need to just remove, yes, exists, so I will need to use the force flag. No. Okay, now we have more accounts. And now I could copy these accounts from here to the config file and then use them in the scripts or in the daemon. This is how we did it. So, so we have the master account. This is the account we already got through from the node itself, through the goal command. And what we want to do, we want to create assets. Firstly, let's have an overview of what's here. Oh no. Let's do it this way. So we have this main directories: artifacts, assets, scripts. And SRC, this is not used. So in assets, we define the assets. What is the asset? So the asset is either an account, it's ASA, or it's a smart contract. Artifacts is a directory where algo-b stores the output of transactions or of the deployment process. Scripts is a directory where we define the migrations, where we define the deployment scripts, or artificial or like other artificial scripts, where auxiliary scripts which we would like to run and do some checks. Okay, so we want to define assets. So as you've seen, Ras was using REST API to define an asset, which might not be very friendly. Here is how you define an asset using the algo-b. It's a very clean file. It's like a YAML file, which accepts all the parameters for the asset you can see in the Algorand documentation. So here we specify like what's the total supply. Decimals, it's like a precision. Yeah? So as you've seen with Algorand, with Algos, Algo token has 6 decimals, which means that we have 6 digits of the precision for one algo. Unit name, URL, so you can put like many things there. Metadata hash, so here is if you would like to add some reference and like metadata, and you would like to link the metadata with the creation transaction or with the asset itself. Yes, so this is how you do it. Node is like a generic parameter for every transaction, as I already said. Node 64 is the same thing as node, but using the base 64 encoding. So it's or nor. Yes, in fact, you can't use both. You use either one or this. And if I remember correctly, the node B64 has a preference. If you don't specify node, the node B64 will be used. And I think Raz was only roughly mentioning it. Each asset has this 4 special addresses: manager, reserve, freeze, and a clawback. So manager is the one who can change the asset. So for example, you can freeze it. Reserve is where the reserve is, where the reserve can go. Freeze, so is the address which can freeze the asset, and clawback is that it's a special address which will be used to do some compliance changes. So if you would need to confiscate someone's asset, the clawback address is the one which will be used for doing that operation. Okay, I will not go maybe into the details explaining the assets. You can find it in the Algorand documentation. But here's how we will specify it. Okay, so now you want to deploy it. So we need to make the deployment script. Let's go to scripts, and let's start with the gold assets. Thankfully, we don't need to like go through the SDK. We have a very high level object for doing the deployment. So the deployment script is just a JavaScript, or it can be even a TypeScript. It's a JavaScript file which exports a function, which exports default function, and that default function has to have these 3 parameters. So it's a runtime environment, accounts, and the deployer. Runtime environment, it will give you the information about the network you are deploying to. So let's say if you have few networks, I don't know, let's say my test network, the official test net, or the official beta net, or the main net, you may do some different decisions in the deployment script depending on which network you are. The accounts is what we've seen in the config file, is a list of the accounts, and the deployer object. The deployer object also have the accounts, by the way. So here we're just getting the accounts. So what we want to create this gold token using the gold owner account. So to make the gold owner account active, we need to transfer, we first need to transfer the algos there. So John account is like another account, and we will use it also later on in the example to send some gold tokens from gold owner to John. And again, we need to activate it. And to activate it, we are sending 1 algo there. So here what we are doing, there we have this helper method to transfer micro algos. It takes a deployer as an argument. The deployer provides the Algorand client and some extra functionality, so that's why we are passing it there. Okay, so at this stage the accounts are active, and now we want to deploy. So again, we are using deployer. It has the special method deploy ASA. Deploy ASA as a first parameter that takes the ASA name. And how it works, it basically uses the what is that? The name. It finds it here. So each ASA has a name in this ASA definition file. Extract all the parameters and deploys the ASA. It also takes this creator, so who will be the author of the transaction, and can take other auxiliary or let's say other transaction parameters. So every Algorand transaction has this fee parameter, first valid, and last valid. In fact, we found that last valid might not be very intuitive. Instead, we change it to the valid rounds. So the first valid, it says like when from which block the transaction is valid. So let's say that the current block is 1000, but you want to deploy this transaction tomorrow. So you can already send the transaction. You can compute more or less how many blocks are needed. Yes, will be created in 24 hours. So let's say by average it's like 4 or 5 seconds for 1 block. Then you can compute how many blocks are there for in 1 day, and this is what you will set for the first valid. And the valid rounds says what's the last block when the transaction should be executed. If for some reason the transaction will stuck somewhere in the network or in a mining pool or the transaction pool, yes, then if you want to assure that this transaction has to be executed in a certain time, this is what you will use, the valid rounds. Okay, then we will print the ASA info. So the ASA info is again like the special object we are generated based on the transaction deployment and all the parameters we provided. There is one more special feature what the deploy ASA function is doing. It's creating a checkpoint. As you remember at the beginning, I said that the checkpoint is the special file in the artifacts which collects all the information you would need to inspect like the transactions without going to the blockchain. Okay, so now as the last thing, we want to to see and inspect the asset itself. The Tesla deployment script is very similar. It's just almost the same, but using the Tesla ASA and using the Elon Musk account. Okay, so let's do it. I'm going to, I need to remove artifacts, I think. Because I did it before, so, okay. Okay, so now I'm doing deploy command. So deploy command will go through all these deployment scripts and we'll run them. Okay, so here we have the first one. We are transferring algo to activate the Elon Musk account, to activate the gold owner account. So we are here. Now we are deploying gold. So here we have the information. So again, who created it, was the transaction ID, was the asset index or ID. So each asset has a unique, globally unique ID, and it's called asset index. Yes, then we have this asset created. Again, now we're doing with the gold, and now we're going to do with Tesla. Oh, and the important thing, as you see, here we are doing the opt-in transaction. So remember, we had this in the question session. If we want to send gold, or if you want to send any token except algo to any other account, that other account have to have this trust line between the asset and his account. This is what it's called as opt-in transaction. This is what Russ explained as anti-spam method. So here we are opting in to a gold account. Sorry, here we are creating this opt-in from John account to the gold asset, and something similar for Tesla. And this is what you see here. Okay, so the checkpoint files should be created. So let's examine them. Artifacts, script, and here we are. So here is the artifact for the gold asset. Here is for the smart contract, by the way. So again, here we can see who created it, was a transaction ID, and so on. This is also used to protect. Oh, by the way, what's default? This is the network name, and this is used to protect the author of the script to not deploy 2 times the same thing. Yes, because if you just run the scripts, you can all over deploy again and again in new gold tokens. And here, if you run it again, yes, you see that, okay, the checkpoint in that network exists, so it will not redeploy it again. If we do it with the force, I will not do it because it will take time, it will override it. If I remove the file or remove the content or change the network here, because each network is treated independently. 1 second, I have some family urgent. My son is coming. Oh, okay, he's not making noise, so I think it will be nice. Good. So yeah, so this is what the checkpoint is for. It's to make sure that we don't redeploy, that everything is synchronized with the whole tool. 1 second, let me only close the doors. Okay, so then we want to go to scripts. So to not deployment script, but to some auxiliary scripts and see how we can run them. So here we have, for example, a query script. We want to see a John balance. So there is this algo-b deploy command, which we just seen, and there is also run. The difference between deploy and run is following. Deploy, it goes through all the files in the directory, in the script directory, and makes the deployment execution. Run, on the other hand, is using the same environment, the whole thing we built, to run some in a high level like auxiliary scripts. But there is some limitation. So run, for example, will not have an access to the deployment commands of the deployer. He will have an access to the Algorand client from the SDK. He will have an access to the accounts, to the network, to everything. So he can query the blockchain. He can create any transaction. So if he wants in a hard way, he can also deploy the asset. Yes, but it will not go through with the checkpoint. It will not go through the deployer. So, okay, so let's see. I want to run the script. I want to query, and so let's say I want to query John balances. So John has 0. So I don't remember what's the asset ID 8. I think it was here. So 8 is Tesla, right? So we have it here. So John has 0 Tesla and 0 gold. We have another script. We can transfer quickly the funds. So let's do a transfer. I want to transfer. Oh, firstly, I want to fund the John account. Let's do it. It wasn't done so far. Okay, done. And now I want to transfer the gold to John. So as you can see, it's using the same, here's the script, it's using the same high-level functions. We are in the same environment, but it doesn't change or check the checkpoints. At the same time, this is very important. So we are using deployer to get an information about the gold. So we don't need to remember what's the address of the gold or what's the asset ID of the gold. It's using the checkpoint file to extract it. And what's also important is that if you play with it on a different network, so let's say the beta net, the official beta net, or your local network or the main net, these asset indexes will be different because each of these networks is different. And here it will solve all of these problems for you because the checkpoint is per network. Okay, so here we created here we transferred a gold to John. Now we can inspect it. So gold is asset ID number 4. Okay, let's query the John balances. Okay, perfect. Yes, now we have John has a 1 gold. Previously he doesn't have. As you can see, whenever so why this is not free algos? This is not free algos because John made an opt-in transaction for holding the gold, and this cost him. Okay, so now we want to transfer Tesla. Same thing. Okay, so now we see that here we print again all the assets. Here you remember John didn't have as Tesla. Here we print all the asset holdings in the transfer script. Now we see that John already has gold. So maybe let's try to Tesla. Let's run it again. He should have, after second run, should have 2 gold tokens. Great. We can confirm it with the query. Perfect. This is what we have. Okay, so this is what's Algorand Builder. It's in the early version, in the beta mode. Next steps are improving the documentation. So the documentation, let me walk you through it. Can you see the screen, the GitHub, just to check it up? And so there is this docs directory here. Here is information about the config. Here are details about the execution, of the execution work. Again, here is the link to the specification. Here is how to run with the TypeScript. We want, like the next step, we also want to provide a template for the TypeScript projects. On our pipeline is to to do more high-level functions with the smart contract. So now we already have a smart contract deployment function. We have a compile. So I can show you how the compile works, but I would need to change builder to my local, okay, dev mode, because I have it here. So here I have where is that? Here I have the project test, and I have the in the scripts I have some assets. I have some smart contract code. So the smart contract code checks. So here there's the smart contract basically checks. It's a very, very basic one. If the provided fee is less than 1,000, no, 10,000. Yes. So here I'm running it with will be dev oh yeah, running on a different node because here I have different configuration. I would need to stop it here and go here, start a different. Oh, okay. The directory changed. Okay, I will not show you here now. No, it should be like this. Okay. No data backup. No, okay, no data. Okay, now we can do it. Invalid API token. Oh, I need to change the API token. Oh, sorry. Okay, I will skip this one. Does anyone have a question? Okay, I think nobody has any question. Last 1 minute. Yes, that was a long session, 3 hours. Okay, so I think, Jean-Marc, we can wrap it up.
Thanks very much, Rob.
Thanks, Patrick. Thanks for joining here. Wow,
Okay,
that
great.
was like a long constant session. 3 hours, and we are still 11 people. But
Yeah. No, it was very interesting. Thanks a lot. So we can I can stop the recording and.
Before I be stopping, I want to again thank you to Martinas and Amit for for developing together this tool, and yes, hope we'll quickly go to the next stages.
Great. Thanks to the DevChain community. So bye bye.
Bye bye. Thank you.
Thank you to Algorand also.